All right, so my name is Cory Brown. These are a couple of the handles I don't tweet at. I'm just terrible at that. But if you DM me, I'll respond. I am at NAV. I'm staff engineer at NAV. And that's who I am. So a little bit before we get into any of this, just an idea of, give you guys an idea of a style that works well for me. I don't do terribly well in a lecture format. It's very back and forth. So if you got something to say, you got a question, some kind of heckling, unless your name is Matt Polson, shout it out. We'll have a dialogue. It worked a lot better that way for me. And it's a lot more fun because I really get like energized by it and I get a little crazy. You want to see crazy? Okay. So in less than, who's heard of a monad before? Who knows what a monad is? Who can explain what a monad is to someone else? Down to one. All right. So today, in less than 15 minutes, you are going to understand, not only understand what a monad is, you'll be able to explain it to someone else. And then in closer to 45 minutes, you'll be able to say why they're interesting and how you could possibly use them. But you'll at least know what they are in 15 minutes. In fact, you likely already do know what they are. You just don't know it. Okay. Monads have the kind of curse, or they're believed to be cursed. Douglas Crawford once infamously said that once one understands what a monad is, one loses the ability to explain it to others. So, and that has actually ended up becoming kind of a self-fulfilling prophecy around monads. But we're going to break that curse today and do it pretty easily. So let's start off with an obligatory definition. A monad may encapsulate values of a particular type, creating a new type associated with specific additional computation. Clear as mud, right? So, as a visual example, suppose we have a string that's a type. We wrap that string in a monad. Now we have a monad string. So that's not really sufficient, is it? Let's break it down a little further. Clear on this? We have a string. That's pretty easy. Oh, nope. Wrong way. Jumping the gun. We have a box. Now, don't get hung up on the syntax. For our purposes right now, this is not an array. It is a box. It is a container, generic. Holds a value. Okay? We can take our string, we put it in a box. Now we have a string in a box. Very useful things in boxes. Now let's suppose we have a function. This is just a plain function. This function, it takes a string and returns us the length of the string. Right? Nothing complicated here. Does this work? If we pass our string in a box to our function that expects a string, is this going to work? It will not work. Why not?
Because it's a box.
Because it's a box, not a string. This wants a string, right? So, next one, come on, let's go. Oh, that's the end of that one. Oh yeah, that one more. Here we go, here it comes, it's coming along. The cool thing about our box, though, is that it has a method that knows how to hand its value, its internal value, to a function. And this is important about for these kinds of boxes that we're going to talk about. It has the ability to take the value that it encapsulates and hand it to a function, and ultimately return a box value again. So a box that contains a value and knows how to expose that value just to a function is called a functor. Funny word, functor. Knowledge about what a functor is not strictly necessary to understand monads, but it gives you a language to use in describing it. We'll mention them again, but again, they're not necessary. Let's say we go back to our example of where we have a string in a box. What if we don't have our string? What if we don't quite know what our string is, right? We're going to eventually run our function on that string, but we don't have it right now. What do we do? Well, as you might have guessed already, we can, if we have this function here that goes and gets our string, and man, I'm going to use my computer here. This is much better. And then we want to map over that string to do get our string length. This looks very familiar. What does this look like? This is almost perfectly, other than Matt. Does that look familiar at all to anyone?
Promise.
A promise. If we change our map to a then, hopefully it's clear that we're actually dealing with a promise here. They work identically in terms of the ability of our promise to hand its internal value to a function and returns a new promise, right? That's how promises work. Everybody know what a promise is? Everybody familiar with promises? You use promises every day? Who doesn't? You guys are really active. You don't use promises? Well, okay, hardly. But this should still be pretty familiar. Okay. So now you guys know Kung Fu. Let's make it a little more clear, right? If we have a function that gets our value through a promise, right? We resolve that promise to 42. This is the same thing, just unwrapped from the fetch. Same idea, still returns a promise. And now you know what a monad is, right? You do, you just don't know you do yet. So let's go ahead and break this curse real fast. What's a monad? Oh, you know what? I didn't really explain that. Let me back it up a minute. What does a promise do? What's its role? Not fetch per se, just generically a promise. What's it do?
Gives you something asynchronously.
Okay. Yes, it gives you something asynchronously. Because it's got to be asynchronously because why? Because there's some work it has to do in order to resolve or potentially reject, right? That's what promises resolve and reject. That's their whole that's why they exist, to either resolve or reject. But if it resolves, it has to know how to do it. There's some methodology involved to determine whether or not it resolves. In this case, in the case before, we're just immediately resolving. Yes, actually, right? We're immediately resolving to 42. So this could just as easily do some crazy complicated thing in order to get to 42. And we can encapsulate that inside the promise, right? It's all wrapped up inside there. And the user of this promise doesn't really need to concern itself about how it got there, just cares about what the result is. This is not unlike monads. Because a monad is just a container for a value that does some defined bit of work in addition to passing the value to a function. Okay? So it's got the map. It passes that just like an array map might have, except instead of only just passing that value to a function, it also does something else. Now what that something else is very much depends on the monad. But what makes it a monad is that it does something else. And that something else is encapsulated inside of that thing we're calling a monad. Is it a pretty simple definition? Is it clear? Is it confusing? It's very slight movements. I gotta pay close attention to your heads. Is it up or down or left or right? Or alternatively, you could just shout it out. That'd make it my life a lot easier. You're an idiot.
Yeah, the heckler.
So do you think you could explain what a monad is to someone else? What is it? What's a monad? I helped you off. Like, really? What's a monad?
It's a container for a value that doesn't define bit of work and passing that value to a function.
That's exactly what a monad is. Precisely. So next time so when we started, who was not able to describe what a monad was? Who thinks you can now describe what a monad is? Who knows what a monad is for? Yeah, that's about right.
That's a different story.
We'll get to that. But conceptually, hold in your mind, a monad, just a container. That container does stuff to the value that it wraps. What that is, I don't know. Might be shady, but it does stuff to it.
Like a magic box.
Magic box, not just a regular box. It's a magic box. Of course, there is a little bit more to monads than just that. There are things like associativity, left identity, right identity, lazy evaluation. Those are all things that technically are required to be a monad, but those are not actually the hard bits to understand what a monad is. The thing that trips everyone up is the fact that it's a box that does something. Because we all want to define, because what we want to do when we say, well, what's a monad? Well, see, it's a functor in the category of endofunctors, and which of course is actually a stupid definition, because everything in programming is if it's a functor, it's an endofunctor because it maps to the same category. But you don't need to know that. So, and if we want to, oh, how do we get there? This is fun. Promises are not strictly speaking monads, but they're close enough. They demonstrate the principle more than sufficiently. So, if someone describes something as a monad, what do you look for? That's a container. Container for
With a cat in it.
a box with a cat in
An
it.
extra bit of work is capsule.
It's the extra bit of work, right? Yeah, it's a box. It will definitely be a box. Like a monad, not just a functor, is the fact that it does something to that value in the box. Okay, now we get to the good stuff. You know what a monad is, but most likely you don't care. So what? Now I can explain to someone, but I will never have the need to, because who gives a crap about monads? Well, why is it even a thing? Like, why do we go through all the effort to take the perfectly good value we have, shove it inside of a box, put that box in another box, mail that box to myself, and then hit the box with the... You guys got the reference? Okay. Oh, you guys are rough. Why do we go through the effort of taking a perfectly good value, putting it inside of a container, then having, in order to apply a function to it, we have to put it through a map, and then on top of that, if we want to do something, like we hide away this other piece of work inside of this thing we call a monad. Why in the world would we do that? Any ideas?
So it's something to do with like chaining and.
Ooh. Yeah. Abstraction. But more specifically, another action or shun word.
Right, that goes right along with that.
Yes.
Like, I don't want my code to care about it, right?
Right, exactly. So we often have things that we want to do. Think again, go back to promise. Promise is your quintessential mental model for a monad, and why a monad might be useful. Why are promises useful?
Callbacks aren't fun.
Because callbacks are not fun. Why are callbacks even necessary?
Because things happen later.
So what does a promise encapsulate?
Asynchronicity.
The asynchronicity. That's exactly right. A promise, or in more strictly functional languages, tasks, encapsulate the concept of asynchronicity. A promise is an asynchronous monad, an IO monad. So monads are really about encapsulating a specific kind of work. What kind of work very much depends that you're trying, on the type of monad that it is. Promises encapsulate asynchronicity. Other kinds of monads encapsulate other kinds of things. For instance, anyone have an idea what might be another example of a monad? What you might want to encapsulate? I'm just gauging here. You don't have to.
Like other than a promise.
Other than a promise, what category of work might be valuable to encapsulate inside of a container so that the consumer of that doesn't have to worry about that whole category of problems anymore? Promises, do you have to worry about the category of asynchronicity in promises when you're dealing with promises? As long as you know it's a promise, you just keep venting off the thing. You can return promises all day long and it'll flatten it out and doesn't matter. You don't have to worry about it. Anything else? Matt?
The DOM?
Oh, that's an interesting idea. I haven't explored that. Encapsulating the DOM inside of a monad.
Error handling.
Error handling is a great idea. The first example I have here is logging. The log monad will encapsulate logging. Why would you want to do that? Well, technically logging is a side effect. You guys know what side effects are? What's a side effect?
It's just more than the intended purpose.
No, that's a good guess. A side effect is, how about this? What's a pure function?
There's one purpose.
It does.
Without side effects?
Nicely done.
If you give it the same input over and over again, you get the same output.
Exactly. It is idempotent. Is that how you pronounce it? I've heard it so many
So, yeah.
Yeah. Idempotent. As long as it gets the same value as its input, it will produce precisely the same output every single time with no difference. Also, the thing is that there is nothing that happens that is externally observable, right? So if something happens inside the function, no one should know about it outside the function. It is a total black box. That can't always be true, especially if we're debugging and we want to log something to a console, because a console is not inside the function, it's completely outside the function. Your screen does not exist inside of your function. And so, strictly speaking, it's a side effect. So we can encapsulate logging inside of a monad. It might look like this. Now, for those of you that know monads really well, you'll notice that my examples are trivial and not complete. Don't worry about it. But it might look something like this. We have a log monad, we can produce it, and every time we map over it, we can log what our value is after applying the function. We might use it something like this, where we log our log monad, we create a log monad of 42. As we map over, we want to add 5 and then subtract 3. We can see every time we do that, when we get a map, we get a log 47. When we map over and do the subtract, we get a log 44. And that puts it out to the console every time. Right? It performs the action, it performs the add, it performs the subtraction, but in addition to that, it
Logs it.
Yeah, I'm trying to really encourage you guys to get involved here. It logs it. Yeah, it does. Nope, too soon. All right, there's another one called the maybe monad. What does the maybe monad do?
Encapsulates nulls.
Oh, it does, yes. This is a fun one. Maybe monad encapsulates the, in JavaScript speak, nullish, null-like values, so null and undefined, the only two. So how many in your code bases do you have if something and call it, like, or do something with it, right? You have all these checks. Does this thing exist? If it does, continue on. Null checks, yeah? Is that a common thing? Yes. It's a very common thing. Who likes them? Who thinks that makes beautiful code? Because you're an idiot. In the case, we can encapsulate the idea of null checking inside of a maybe monad. When we map over something inside of a maybe monad, it will skip the application of the function for any time that the value it has encapsulated is either null or undefined. It just won't even run it. And this can help us guarantee a lot of safety in our applications. We don't try to call undefined, because undefined is not a function, if you recall.
It's interesting that you kind of get half this idea in built into a lot of languages, right? You get an optional,
Yes.
like Java, or knowable. And
Yes.
you don't get the like null check behavior, but it's this idea of, well, it's one of these two things. And it's common enough, it's built right into the language.
Yeah.
I don't know why they don't just
For
take
many
it
languages.
all the way and
Not all languages.
Yeah.
Not our language. But it's easy. If you guys notice, here's what I really want you to, one of the many things I want you to kind of grasp at the end of this, I hope, is how incredibly easy it is to make these. There are a couple more methods you might want to add in here, but I mean, look at this. Once you've made this, now you have maybe monads, and you can use anytime. It's fantastic. This doesn't have to be a difficult thing. It doesn't have to be a convoluted or complex thing. They're very easy to produce. So this is the implementation, or an implementation. There's many ways to implement it, and here's how we could possibly use it. Suppose we have an object, and we want to get a property deeply off that object. We could use low-get. We could use a maybe monad. You can see in this example where our property exists as we map over it, and this is contrived, so bear with me. We wouldn't write code exactly like this. As we iterate over and go deeper and deeper into the object, once we get there, if that exists, we get just 5. 5, that's our value. In the case of we have an empty object and we attempt to deeply arrive at a property that isn't there, we end up with a monad that contains nothing. But it didn't blow up. That's important. Related to the maybe monad, any questions so far? Confusion so far? Don, I don't even know what question
Just
that
an
is.
observation, but so like the result is yet another monad, right?
The result is always another monad, yes. Much like when you return a value inside of a then of a promise, what does it return? Does it return the value? No, returns a new promise. So that's why you can keep thenning every single time, because the return value is a new promise.
So in your last example, with the nothing, if we were to log those, what actually would come out of it?
Well, in this implementation, it would be either undefined or null. A more robust implementation might say, are you undefined or null? I'm setting you to null, or something like that. You know, these are very naive implementations to illustrate the point, but yeah.
I think she was asking at each of those steps, each map. You wrote it up, is that correct?
I wasn't, but that's a good question too.
What do you think would happen in that case, looking at the implementation?
I would think it would do null for all of them.
Every time you call map, it says, am I nullish? If I'm nullish, just return what I currently am. If I'm not nullish, then call the function on my value. So if at any time you hit null all the way down, turtles all the way down, nulls all the way down, until you end the monad pipeline and you do something with what you have.
I don't know if you said this, but like it's returning itself, right? So you can.
It's returning a new instance of itself every time.
Right.
Yep. So that's why the question right here was, what does it return? Always, monads always return another monad. They never not return the monad when you're using map. There are methods that unwrap that value to give it to you. I'm not talking about those today. We can talk about those after. So this maybe monad. How about the either monad? Related to the maybe monad. The either monad encapsulates branching. So the if statement, the ternary, essentially. This is an encapsulation around the turn area. It allows us to make a decision and go either left or right depending on some condition. You could use an either monad to implement a maybe monad if you wanted to. Pretty cool. And in fact, the either monad is most often used to deal with error handling specifically. So try catches. Who likes try catches? I hate them. They make code look really ugly. The either monad can encapsulate that for you. So if you try something and it's successful, it can go down the right path. If it fails and catches, it can go down the left path. Is that right? Do I have the right, left, and right? So branching, right? A or B. Here's an implementation of it. And the cool thing is, this is by default error handling, the way I did this. So we have, when you map over it, you give it a predicate. In this case, I'm just checking, are you an error? Are you an instance of an error? And if you are not an instance, or if you are an instance of an error, then I'm going to, apparently I'm wrapping in an error again. And if it's not, then I'm going to, the default is just return the value itself. But you can give it a predicate and then a right and left values or functions to apply. And so if we were, for instance, parsing JSON, which you always have to try and catch because JSON parse explodes if it can't parse it, we can use an either monad to do that. And pull out, and then map over it and pull out the data that we need or whatever we want to do with it afterwards. Those are all the examples I have for monads. Use cases of monads. So that's all I got, guys. Any questions?
So if we're talking about like trying to implement something like this,
yeah.
I think a lot of us use React or even in Angular, whatever. So just trying to think of like coming up with some contrived example for like using it in the instance of like, yeah.
So
using it.
for the React developers, I'm not trying to be exclusionary. That's where my experience lies. For React developers, who's used Recompose? Okay. Recompose has had a lot of higher order components that were doing almost exactly what these do, just in the form of a higher order component. Branch is one, for instance. If you take that same concept, if any reason you would have had to use one of those can be turned into a monad and used inside of your render or inside of your component. That would work the same way.
So especially with, since hooks are all the rave nowadays, and if you're getting rid of your class components, and you don't want to use higher order components, to create some sort of thing like branching, a branch monad. So then.
Yeah, now since you brought up hooks, and we talked earlier about side effects, if you are using a monad, where in that scenario would you have to use them? You have to use them inside of a use effect hook. Because all monads, mostly, yeah. For our purposes today, all monads produce side effects. In fact, that's their point, it's the purpose of them, to encapsulate a side effect. All the examples we saw in here, branching, error handling, the logging, all those are side effects. Promises deal with IO side effects. So they encapsulate that. So if you properly use a monad inside of a React component that uses hooks, that monad you should be mapping over that monad inside of a use effect hook. Because effects.
Thinking about I thought of the DOM, making a monad for the DOM. Would something like React Render be considered a monad for the DOM?
No, no. Probably not. Because remember, in order to be a monad, it's not just about encapsulating some concept. It's about encapsulating a value, or rather, containing a value. And then, in addition to that, providing some kind of additional work. So it's not just about encapsulating a thing, it's encapsulating some kind of work,
Well, it's encapsulating a virtual DOM.
which is maybe the value.
So it's
Well, what is the extra bit of
DOM
work?
should look like, and the work that it's performing is
Reconciliation?
that DOM. That's why I wonder if you could consider it a monad.
It doesn't have a map.
You got me there.
Um,
Do you have to have a map?
You can draw parallels, but it is not strictly speaking, not a monad. But they're conceptually.
I think they are very similar, right? Like, they're not the same thing. You probably could.
You could implement it as one.
Yeah, and you almost think of them like fibers, right? So when fibers hit, right, like you have these series of updates that need to happen to the virtual DOM. They may be async because you may be prioritizing animations or whatever. And you need to apply the successive chain of updates to the actual DOM. And the order you do that might be different than the order the updates came in. And so I think there are a lot of parallels. You probably could. I think there actually are some libraries for React for like ClojureScript and things that do similar things around this. But yeah, the ideas are very similar. So I think conceptually, yes. Whether that's actually how it works, and then probably not.
The idea of what a monad does and what kind of problem space you are using it for, I feel like it's pretty much exactly what it's abstracting away certain asynchronous work, which is exactly what React is doing for you. It's abstracting away DOM work that you don't want to have to worry about.
Yeah, like I said, I think you could draw a lot of parallels, but they don't. There are certain things that you can assume about monads that you would not be able to assume about.
That's true.
So anyway, if you guys thought this was in the least bit entertaining and educational, that's really hard for me to judge. I'll be speaking at Utah JS conference. If you guys are going to that, I'll be talking about something slightly different. Monoidal identity elements. I like the weird words apparently. And that's gonna be a fun one. So come to that too. Man, this went a lot faster. Usually I have more interaction. I'm just putting that out there. Yeah, so thanks guys.
Thanks, Cory.